Hello, I'm Rotem Yoeli, and accurate temperature is our goal. Temperature is one of the most important parameters in aluminum extrusion process, controlling production, wastage, cost, quality, and the life of the press. Extrusion of aluminum is one of the most challenging applications for remote temperature measurement. AST is performing this task with great success at the important points that customers need to measure. Press exit, billets, cooling table, die. Measuring the temperature at the press exit is probably the most important measurement and complicated one. Pyrometer with a scanning system enables finding the profile automatically when dies change and thus continuous accurate measurement regardless of the operator performance. Pyrometer is targeted to the inner part of the press mouth. The aluminum profiles are typically extruded at extrusion speeds in the range of 5 to 50 mm a minute, depending on the alloy in use and the profile complexity. Pyrometer position in a manner enables operator easy aiming on profile for maximum accuracy. Productivity is increased as extrusion speed is increased. For example, if aluminum profiles are usually extruded at a low temperature of 520 degrees and the extrusion temperature is increased to 560 degrees, the extrusion press speed can be dramatically increased. When profiles are extruded at very high temperatures, for example between 580 degrees to 600 degrees, the product may be damaged. The scanner is targeted to the press mouth where there are fewer sources of reflection that disturb the temperature reading. The pyrometer scanner is aimed into the press tunnel to measure as close as possible. This is a typical case when extruding hard aluminum alloy at low speed. A5 scanning systems. The right choice for aluminum profile, temperature measurement. Illustration on how scanning system provides mounting flexibility. A scan record chart can be used to monitor and learn more about the depth of temperature distribution across the profile. A sophisticated algorithm that enables the pyrometer finding the best measurement spot. The sun is one of the most disturbing sources of light to the pyrometer. We always recommend adequate shielding. Simple and convenient installation to the operator A5S-in with scanner. Measurements as close as possible to the die will enhance the process control and the extruder know-how about its process. Data we collect will be used to monitor the quality of the process and how close we are to achieving an isothermal process. In this picture we are far, and in the next slide we are much closer. Getting close to isothermal extrusion. Most of the process is performed at a steady temperature. Excellent isothermal extrusion at maximum productivity. The temperature is 570 degrees. Profile measurements. AST thermocouple. Verification of accuracy with a thermocouple is the right practice to maintain a long-term accurate measurement, and most important, an excellent high-quality profile. Billets are heated in a heating furnace to the required temperatures, usually around 420 to 500 degrees. The heating is intended to reduce the flow stress of the aluminum alloys and to avoid cracks and surface defects due to high temperatures. Accurate temperature control of billets is therefore very important, not only for good extrusion, but also to avoid burning out the precious energy. Mounting the pyrometer from the right position enables scanning the billet, readout of multi-points along the billet length, and feedback to the furnace on how to improve the heating. Measuring from the bottom will be the right choice in some cases, highly recommended in places with lots of light and when measuring shiny billets. Measuring from afar. Measuring the billet face coming out of the billet furnace. Illustration on how we are measuring the billet face or skin coming out of the billet furnace. Temperature gradient measurement. Achieving the desired billet tapering by feedback to the furnace. In some of the cases, the customer chooses a scanner to scan the billet. Verification of accuracy of the billet's temperature measurement is best done with a 2-wire thermocouple. Good tapering temperature varies from 420 degrees to 520 degrees. Another good tapering temperature varies from 410 degrees to 530 degrees. Each line is 1 billet measurement. Extrusion billet fill data. Analyzing the emissivity variation emphasizes the complexity of the measurement. Billets measurements. AST pyrometer measurement against a thermocouple measurement. Verification data with excellent accuracy. Billets measurements. AST thermocouple, more excellent data we collected. On leaving the die, the extruded profile is cooled through the use of air or water quenches. This is a critical step to ensure proper homogeneous structure, dimensions, and strength characteristics of extrusions. Based on the intended use of the aluminum profiles, they are required to have different mechanical properties, such as strength and hardness. These properties are achieved in 2 operations. The first one involves cooling of profiles in the extrusion process through the proper temperature adjustment and control of extrusions leaving the die. Scanning system above the running table, the only real solution at this stage. Scanning system between 2 cooling chambers. Pyrometer without scanning option cannot complete this task successfully. An old scanning system between 2 cooling chambers. By using the scanner to measure the temperature across the profile, the extruder can adjust the cooling nozzles, thus achieving uniform cooling. Last but important, the die temperature. Measuring the die temperature before loaded to the press, pyrometer model AST A250. Accessories. AST Net, application software for PC. Accessories pictures, partial list. Accurate sensors technologies.